Action.
Action. Okay, so voltage, this made up thing that helps us understand how electric circuits work, right? And so when we define what voltage is, it's the amount of energy carried per each coulomb of charge. So if voltage existed in mechanics, it would be the amount of energy from each kilogram of mass. When you lifted it up, it's kind of the amount of energy that each kilogram of mass has. When you lift it up in a gravitational field, well, voltage is the amount of energy that each coulomb of charge has when you lift it up in an electric field. So voltage is measured in volts, energy in joules, and charge in coulombs. And so I guess an alternative unit for voltage would be
Joules per coulomb.
yeah, joules per coulomb. And so when you buy a battery, like a 1.5 volt battery, that's telling you this battery will give you 1.5 joules for every coulomb of charge that comes out of it. So that's what that voltage label is so important for. This is quite useful as well, because like reflecting back on our what we've learned earlier, our energy, electric potential energy, is EQD, electric field strength times charge times distance. So what happens if we substitute that in over there? Anyone see a simplification coming up?
Q. V equals. Wait, what's that E again?
V equals ED.
What's that E again?
Is electric field strength.
Distance from electric field.
Electric field strength. No.
So E's the electric field strength because it hasn't got the little triangle in front of it. Remember that in this topic, triangle E is energy and E is electric field strength. But hang on, does that mean we've got another unit? If we rearrange this, what's our new unit for electric field strength?
Wait, what is
per meter?
Nice.
volts per meter?
Per meter. And so we've got a new unit. By defining voltage as energy per charge, we've created a whole new unit for electric field strength, which is a really common unit to see because it's really easy when we make an electric field to connect it up to a voltage that we measure on a voltmeter and to measure the distance between plates. It's way easier to measure voltage and distance than it is to measure the number of newtons of force on a charge and how much charge there is. Those things are hard to measure. So electric field strength, most commonly, volts per meter. The last thing we have to add with voltage is it comes by several different names, aka potential difference. So if they ask you for potential difference, they're just asking you for the voltage, and aka EMF, that's like the original name for voltage, EMF, electromotive force, when they used to think that voltage was a kind of force. So sometimes you'll still see voltage referred to as EMF, electromotive force. So quite a few things come out of this definition of voltage. The important things to hold on to are the two ones that are kind of in boxes as definitions, that voltage is the amount of energy carried per coulomb of charge, and that by substituting in for our equation for electric potential energy, we can now write V is equal to ED. Voltage is electric field strength times distance, which gives us that new unit for electric field strength. Cool.